So the last part of this lesson, we're going to talk about something new called compositions of functions. And compositions of functions just basically mean one function and then another function. So you might have heard this word composition in geometry, where you had compositions of transformations, where you did one and then another. So we're just going to be using this parentheses notation. There is another notation that looks like this, but you can save that for later years, okay? And really, we just follow the parentheses. So for example here, the first thing that's in parentheses is to find g of 4. So this is actually an evaluation where we plug in a number. So I'm going to find g of 4. Here's my g function, so I'm going to plug in a 4 for the x. So g of 4 equals -1. So now that I have that -1, now I'm going to find f of -1. So we're taking our answer and we're plugging it in for the x's in the f function. So you could type this totally in your calculator is probably the easiest way. You could also just use PEMDAS to simplify it, but you would end up with f of -1 being 13. If you were doing it by hand, important to make this a 1 first, right? Do exponents first and then multiply from there. So moving over to the next one, this is just a different order. So we're going to start out, maybe try this one first, pause the video. We're going to find f of 0. So f of 0 is 2 times 0 squared minus 4 times 0 plus 7. For these evaluations, you could also just type it in your calculator and look at the table, right? There's multiple ways that you could do this if you wanted to use y equals. So that equals 7, makes sense, we're finding the y-intercept. So we're taking this answer, which is 7, and now we're finding g of 7. So -7 plus 3, plugging that into the g function, is -4. So for both of these, you just get numerical answers. Now, moving on to creating a new function that's a composition of functions. Here we see the notation for c. So this says g of f of x. And we know what's in parentheses here, you know, whether it's a -x or an x plus 2 or whatever, that gets plugged into the function. So f of x, I'm just going to write there where the blue is. So we're doing g of f of x. And f of x is this. So we're doing g of 2x squared minus 4x plus 7. So what that means is I'm taking the 2x squared minus 4x plus 7 and I'm plugging it in to the x in g of x. So it's a plug-in. So this equals negative, we're going to plug this in for x, 2x squared minus 4x plus 7 plus 3. And that's because g of x, I know it's all the way at the top of the page, is -x plus 3. So I just plugged this in for the x. So any simplification needs to happen. We have a negative sign out here, so I'm going to distribute my -1. So this becomes -2x squared plus 4x minus 7 plus 3. So -2x squared plus 4x minus 4. Now, that is a bit of the easier way. For f of g of x, just due to the nature of this, if I plug in g of x to f of x, that means if I go up here, that I'm plugging in the -x plus 3, which is g of x, to the f of x function. So we're going to end up with that situation where we're going to have to do double distribution. I'm just going to write it down and then I'll move the page up. So looking at my f of x function, which is up at the top, I have 2 times -x plus 3 squared, and then minus 4 times -x plus 3, and then plus 7. So because of this section right here, right, we're going to have to write that twice because it's a binomial squared. So I have 2 times -x plus 3 times -x plus 3. And then here we can distribute. So I'm going to get positive 4x minus 12 plus 7. I just, as I like before, prefer to do this first, and I'm gonna do that middle part in my head. Negative x times negative x is positive x squared. Here I get a negative 3x, and a negative 3x is negative 6x, and then 3 times 3 is 9. So I did those middle terms together. We'll copy down the rest of it. This combines to negative 5, and now we're going to distribute our 2x squared minus 12x plus 18 plus 4x minus 5. So we have 2x squared minus 8x plus 13.